population. Okay, the sampling distribution of the sample mean. The sampling distribution of the sample mean. Okay, in this topic, we want to discuss on sampling. Okay, in statistic, is quite impossible to survey or to conduct a research on all population. Okay, so normally we do sampling. So we have seen, okay, why we need a sampling, but the risk when we do sampling, we tend to make an error. We tend to make an error. So we have already seen that using a sample to acquire information about a population is often preferable to conducting a census. Okay. Generally, sampling is less costly and can be done more quickly than a census, and it is often the only practical way to gather information. For example, we have 34 million. Okay, let's say we want to do all Malaysian. You KKM want to conduct a test, okay, on COVID. So imagine 34 million, 34 million. So that's why we need some sampling. Okay, when you have a cases and then you are a person that is lost contact, and they start quarantine you. Okay, so this is a sampling. Okay, so this is one of the sampling issue that you can see now when we having a COVID problems. Okay, so important sampling. Although we know that when do sampling, we tend to get some risk, but that is the most costly, the most less costly, and it will be done more quickly. Okay, that's why when you do sampling, you need to look on some sampling error. However, because the sample provide data for only a portion of entire population. Imagine, for example, you want to make an inference. For example, you take 100 students, and then you said 100 students. We have discussed this in our first meeting on first topic. 100 students, and then you collect on their age, and then you make an inference that all student at SOC, the average age about 21 years old. So we can see that we cannot do all student SOC students, so we do sampling. So because that a sample provide data for only a portion of entire population. So we cannot expect the sample to yield perfectly accurate. So you cannot expect perfectly accurate information about the population. So we should anticipate that a certain amount of error, we call sampling error, will result simply because we are sampling. Okay. The sampling error. So what is the sampling error? The sampling error, the need for sampling distribution. Sampling error. Okay, what is sampling error? What is the definition of sampling error? Okay, is the error resulting from using a sample to estimate a population characteristic. So direct the sampling definition, you know that sampling error. So you will get some and accurate, because you are using sample to estimate a population characteristic. Okay, and then look first example. Okay, let's say in this example, we look on example of IRS, Tax Internal Revenue Service. So it publish a figure, yearly figure. Individual income tax for year 2005, the mean tax of individual income return was 10,000. $319. So this is example in US nah. So we take dollar dollars like that. So in actuality, the IRS reported the mean tax of a sample. Okay, the sample is only 292,096 individual income tax return. Or total more than 130 million. Actually, people pay 130 million pay, but they are only take 292,000 and make a calculation that the mean for individual tax return was 10,000. Was 10,000. And then in this example, let's look. Okay. So what the population? What is the population? And what is the variable that is under consideration? And if we see that the mean tax reported by the IRS, a sample mean or the population mean, sample mean or population mean, and we expect that the tax of 290,000 return sample by IRS be exactly as the mean tax of the population of all individual tax return for 2005. Okay, how we can answer question about sampling error? Okay, for instance, is the sample mean tax. Okay, sample normally for the sample we use this notation X. X bar, called the S bar. Reported by the IRS likely to be within 100 of the population mean tax. Okay, mean tax of the population. Okay, let's go on. What is the population? So the population all individual So 130 million. So that the population So all people that pay individuals income tax return, it's all the population. Okay. The variable, so the variable that you see here is a tax, amount of income tax, not height, year, or so amount of income. Mean you have some amount that from the amount it can be tax. They are tax for your incomes. Okay, amount of income tax. So that the tax variable is X. Okay, the mean tax reported is a sample mean. Okay, so the mean we look. If you read carefully the example, the mean sample, the X bar of the 290,966 written samples already said. So you know that is a sample. The mean tax that be reported is a sample mean. It's not the population. Faham kan? Kalau kamu baca ayat tadi, dia menunjuk kepada sample mean, not a population mean. So it's not the population mean of all individual income tax return for 2005. Okay, we cannot certainly expect that the mean tax sample by the IRS be exactly at the same as the mean tax. Definitely memang tak sama lah, because let's say you want to do population, population for 130 million, definitely will not be same. Takkan same dengan 2000 that the sample mean that you have for the amount of income tax. So the sample by the IRS to be exactly same with the tax of the population of all individual income tax return for 2005. So sampling error is to be anticipated. So you have to terima dah. You have to agree lah with the figure, the mean figure for the income tax return. Although it's not represent all the population. So to answer question about sampling error, we need to know the distribution all possible sample mean. Okay, let's say all possible. That could be obtained by sampling 290,000 individual income tax. That distribution is called the sampling distribution of the sample mean. Of the sample mean. So in sampling error ni to highlight here that when we do sampling, we have to accept, we will have some sampling error. Maybe you have kaedah lah. You will do some kesalahan dalam you buat sampling. Tu maksud dia sampling error. Okay. Another, we look on what is sampling distribution of the sample mean. Okay, so macam mana nak sampling distribution of the sample mean lah. Macam nak pujuk your result lah. When you have the result, you say okay lah, we accept lah this sampling error and with the mean of this sampling. So distribution of statistic, possible observation of the statistic for sample of a given size is called the sampling distribution of the statistic. Okay, in this chapter, we concentrate on the sampling distribution of the sample mean that is of the statistic X bar. X bar ni mean we concentrate on sampling not on population. So, let's say you have a variable X. Tadi we have discussed the variable X is amount of income tax and given sample size. The distribution of the variable X is called the sampling distribution of the sample mean. Okay, confused kan? Confusing. Sample distribution, sample mean. So it means that when you do sampling, okay, and then you look on the mean of your variable, so you call lah the mean of variable ni the sampling distribution of your sample mean. So the sampling distribution of sample mean is the distribution of all possible sample mean for sample of a given size. Possible lah, mungkin kan bila you tengok sampel 10 ni, okay, and then you take lagi another 10, we buat sampling lagi, mungkin the sampling, the mean sampling will be different for a given size. Okay, in statistic, the following terms and phrases are synonym. Okay, when you say sampling distribution of the sample mean, distribution of the variable X, distribution of all possible sample mean of a given sample mean, it means you are referring to the X bar. You refer to the X bar. Okay, example we look on this. Okay, so let's say you have population 5 players A, B, C, D, E, and then you have a mean basketball. Need to highlight lah macam mana sampling and with the population. Okay, let's say this is a population. So your population is small population. You have 5 players A, B, C, D, and E. And then from this A, B, C, and D's population, you record their height. Okay, so player number 1, the height is 76. Player number B, 78. Number C, 79. Number D, 81. Number E, 86. Okay. Obtain the sampling distribution of the sample mean for sample of size 2. Okay. Katalah you nak pilih from this 5 ni, you nak sampling 2. You sample 2. The sample player ni 2 will be your sampling. And then you want to look. If you take 2 player ni, okay, what is their sample mean? What is their sample mean? Sample mean. And then you make some observation now. Maybe you take A and B, A and C, A and D, D and E. So make some observation about sampling error when the mean height of a random sample of 2 players is used to estimate the population mean height. Then find the probability that random sample. So random sample you take lah mana-mana random sample. Mungkin you take A and B, A and C, A and D, mana-mana lah as a sample size of 2. The sampling error made in estimating the population mean by the sample mean will be 1 inch or less. That is, determine the probability that you will be 1 inch of your mean population. Okay, let's look on the result. So this result this buat sampling lah. Sampling okay, kata bola dia play A dan B dapat 70.7. A with C 77.5, A and D 78, A and E 81, B and C to 78.5, B and D 79, and then B and E 82, C and D the sampling mean is 80, C and E 82, and D and E 83. Okay, this is your sampling sampling. Population 80. Ada tak dalam sampling mean ni dengan sampling population ni sama? Tak ada kan? Gitu. Okay, ada 1. C and D ni 1. So C and D ni, the sampling mean you and this your mean of your population. Kat sini kebetulan ada sama. Okay, so mula you compute the population mean. So the population mean is 80 and then you buat sampling to size and ada satu C and D you get 80. Table. So table 1 ni give the 10 possible sample. The second column the corresponding height, values of the variable height, and the third column the sample mean. The sample mean. Tapi kalau you tengok size 2 je. So 80 tapi dia sama tapi dia tak mewakili all players. All players. So continue. Okay, figure show ni. If you look on the figure show ni, show the decision of the sample mean. Okay, sample mean. The sampling decision of the sample mean for sample of size 2. Okay, for size 2 ni ada satu yang ni, this is your mean and this is the blue, the green the green ball ni in your figure 1 is the sampling of size 2. Okay, sampling of size 2. So from the table 1 and figure 1, we see that the mean height of the two players selected is likely to equal. The population of mean 80 inches. In fact, only one of the 10 sample has a mean of 80 inches. Kalau you tengok pun, dalam one of the 10 sample tu, satu saja. Only one from 10 sample yang you taken ni has a mean of 80 inches. So, probability ni only 1 over the 10. Maybe you do 10 sampling, only one sampling je. Sama with the population mean. Or we say that 10%. That we equal with your population. So, some sampling error is likely. So, masih lagi ada sampling error in your sampling if you take two size. To highlight dia, it mean the sampling ni you will always keep probability you will have some sampling error. Tu je nak stress in this example ni to stress walaupun you say that our sampling mean 80 and our population is 80, okay dah kan. Maknanya kalau we take 2 pun we get the sampling. Tapi ingat 1 over the 10 sampling yang you buat. 10% je that will be equal to your mean population. So some sampling error is still ada, is likely. So to say that to give some stress here that you need to accept that when you do sampling there will be a sampling error. Okay, sampling error tu you can accept. Okay, so figure 1 show that 3 of the 10 sample have mean within 1 inch of the population mean. Kan, kalau tengok pun ni 81, 82 pun kan more than 1 inch of the population mean. So the probability is 3 over 10, 0.3. The sampling error made is estimating by the mean population by X mean sample will be 1 inch or less. So we can say that 30% that the mean height of the two players selected will be within 1 inch of the population. 1 inch sikit dah kan of the, so buatlah sampling, tak payahlah nak ambil all population. So this is another figure. If you have only one, your sampling is 1, your sampling is 2, your sampling is 3, your sampling is 4, and your sampling is 5. So to highlight here that the mean population of your sample and the mean population of your mean population of your sample and mean population of your sampling, the distribution is somewhere dekat-dekat, taklah jauh sangat. So figure illustrate that the possible sample mean cluster more closely around the population mean as the sample size increase. So nampak kan, kalau you nak dapat yang tepat lagi, increase lah you punya sample size. Okay, compare kalau you ada 2 dengan compare you ada 4 kan, nampak dekat lagi dah mean sample you kan. Compare kalau you ambil 5 memang semua memang dapat tepat dah with the mean population. So from this result ni, if you want to reduce the sampling error ni, your size sample must be good enough. The result suggest that the sampling error tend to be smaller for large sample than for small sample. Kalau you ada large sample, nampak kan? Large sample ni you see compare N equal to 4 dengan L equal to 2. Nampak kan perbezaan the mean sample. So, if you want to reduce the sampling error, your sample size need to be bigger. Need to be bigger. Okay, and then in this example, for this example, figure 2 reveals that for sample size 1, okay, kalau you ada sample size 1, nampak ni sample dia. Okay, so 0% error. Okay, kalau you ada 2, 20%. Okay, if you have two possible samples within 10 ni, number possible sample 10 ni pun 20 error, 60% error and 100%. 0% with 0.5 of your mean population. So if you have less sample, maknanya error tu banyak lah. Okay. And then we look on the sampling error. Tadi to stress lah, the slide to stress that you have to accept. So if you want to reduce the sampling error, your size sample must be good enough. The sampling must be good enough, then you can reduce the sampling error. Okay, in sampling error ni, we can make the following qualitative statement. The larger the sample size, the smaller the sampling error tend to be in especially estimating a population mean new by a sample mean. Okay, so what does it mean? If you want to reduce the possible sample mean cluster ni, okay, so increase the number of cells. Increase the number of sample size. Okay, and then we do some practice here. Not practically, okay, in reality. So when you want to use population, for example, we have used the height of population kan, 5 basketball player ni, to illustrate and explain the importance of the sampling distribution of the sample mean. Okay, for that small population with non-population data, we easily determine the sampling distribution of the sample mean for any particular size by listing all possible mean sample. Okay, tadi we have the example tu 5 kan, 5 players. So easy lah you nak buat kan. Kalau you ambil 2 size berapa, 3 berapa, 4 berapa and 5 berapa. So it easy. In practice, however, the population we work large. For example, kalau you tengok in Malaysia now, if you have one cluster, for example, in Selangor, one cluster ni, just wonder you have 10,000 cluster, then you have to do testing. Katalah you tak puas hati, you kata, oh tak boleh lah dapat cluster dekat apa ni, orang kerja kilang ni kan. Buat semua sekali orang yang duduk kat Selangor tu. So you imagine that's why kalau you tengok ni, why we have the cluster kan, for the KKM. KKM, okay, this cluster kan. So this is the reason because population which we will are large and the population data are unknown. So proceeding as we did in the basketball player example isn't possible. In reality, tak possible you nak buat semua testing dekat population. That's why you ada cluster, ada positif, ada, so you buat dah cluster kan. Ni pun kita tengok in Malaysia ni, you have the cluster everyday record on COVID-19 cases more than 3,000. More than 3,000 tu cluster tu. You imagine. So stay safe. So untuk peringatan for myself also stay safe and follow SOP. Follow SOP because we cannot see the virus. If you can see the virus, then you can take precaution so the best. And then for the Muslim, you pray a lot okay, it's impossible lah so what we do then in the usual case of a large and unknown population. So ni banyak ni lah macam teori lah, but the theory is important. So when you nanti kan, now when you at degree, you don't see any problem. But when you do for your PhD, you do for your dissertation master, then you know, oh, that's why we need to do sampling. Because you don't have 10 years to complete your PhD, you don't have 10 years to complete your master. Master, at least you have 1 to 2 years. For PhD, you have only up to 8 years. 8 years. That's why you need sampling. Okay, so itulah sikit about sampling. So, we can use mathematical relationship to approximate. Ni lah kita pergi kepada macam mana you want to use mathematical relation to approximate the sampling detection of the sample mean. Inilah formula dia yang panjang-panjang sangat kita bercerita ni. Sebenarnya kita nak cerita yang ni je lah dalam topik kita ni. Okay, ini So macam mana you nak cari mean of the mean sample? Saya pergi cepat sikit lah. Dah faham kan? Okay, inilah formula yang dalam kelas kita yang kita nak apply in our statistic class. Okay? In our statistic class, okay? So when you have a what we call mean sample So for when you have the mean sample, okay, you use the standard deviation for your sample size. For your sample size n. So this standard deviation of the variable x ni, mean the variable of your mean equals the standard deviation of the variable under consideration divided by the square root of your sample size. Okay, katalah bila you dah ada mean population, you want to find the standard error standard deviation for the mean sample. This the formula. So you look on the standard error, standard error ni, standard error given divide with the square root of your n sample. So if you have sample size, standard deviation ni katalah dia bagi you sample mean, lepas tu dia bagi you standard deviation, you want to calculate calculate. So untuk dapatkan standard deviation of the sample mean, you kena guna this formula. This formula. So take the standard deviation given, okay, over the square root of n. Ni nampak simple ni. Tetapi kena ingatlah ni. So this is a sample standard deviation of the sample mean. Okay, kita tengok one example So one example ni how you determine the population standard deviation. Okay, let's say this is your, okay, so I terus pergilah okay, dah calculate ni. So this is your standard deviation for your population. So standard deviation for population, okay, you ambil the standard deviation population ni, you divide with your size n, dapatlah standard deviation for your sample size. Faham So standard deviation of your population population bahagi divide with square root of your sample size. Sample size, so you dapatlah standard deviation for sample mean. Ingat ni, sample mean ni selalunya dalam soalan dia tak bagi, tapi dia akan bagi you sample, dia akan soalan, the test will be given you population of standard deviation of population. Okay, you ambil figure the standard deviation of population ni, you bagi with this formula to get the sample deviation of sample mean. Okay, macam mana you tahu that it's a standard deviation of sample mean, you kena guna this notation. Notation ni penting lah. Notation ni. Nak calculate the standard deviation of ini formula dia. Kat mana you nak daripada from this. From this standard deviation population. Ni you nak dapat this one, kena bahagi dengan your sample size, dapatlah sample deviation sample mean. Okay. Okay, look one example Ni example ni direct je, ni senang. So katalah Siapa yang malam-malam nak fikir pasal probability chapter kan? Bawah ni. So you concentrate on this topic. So sampling error ni, okay, let's say in this sample example ni, the mean rent paid by all tenants in a large city is RM 1,050 ringgit. With a standard deviation of RM 235 ringgit using a sample size of 100. Calculate the mean and standard deviation of sample mean and your sample portion will be the same. Sample mean, sample portion will be the same. The standard deviation of your sample mean will be 2 to 5. Standard deviation 2 to 5. 2 to 5 here. Divide with your sample size 100. Ni your sample size 100 kan. So you get lah the sample standard deviation of your sample mean. So standard deviation of your sample mean, this is the figure RM 22 ringgit 50 cent. Okay, any question about the mean and standard deviation of the sample mean? So in this topic, sampling error ni, normally the population mean and population sample will be same. Okay, and then you use the standard deviation of the population, divide with your n here, 100 ni, then you get the standard deviation of sample mean. Okay, another example ni, the mean living space for single family detached home is 1,742 square feet. The standard deviation is 568. Okay, for sample of 25 single family detached home, determine the mean and standard deviation of the variable x and repeat part A for sample size of 500. Okay, sample, we know that the mean here, okay, like the information, so we have the mean 1742, standard deviation for our population 568. Okay, and then our sample size 25. Okay, this one, okay, go to the solution. Number 1, your mean population and your mean sample will be same. Standard deviation of mean sample, okay, take the 568 here, 568 here over the 25. So be careful, the sample size is 25, so this is your standard deviation sample mean. Okay, when your size is 500, just for this divide with the sample size 500, then the standard deviation of your sample mean is 25.4. So you can see that your standard deviation is much smaller. It's much smaller when you have a bigger size. Bigger size. Okay, so let's do exercise 1. I give some question, some time, give you time. Okay, so now is 3:44. So I give you about 10 minutes lah. 10 minutes. Babies normal, focus on birth weight of babies. Okay, the mean of the babies is 3369. Okay, and the standard deviation is 581. So identify the population and variables. And then for the sample of size 200, find the mean. Okay, standard deviation of all possible mean weights and repeat part B for sample of size 400. Okay, 10 minutes. Try to this exercise.
Population is all baby and the variable is birth weight. So first for the B, 581 divide the 200 and we got this. And for the C, the question 1 for 400, so we get this.
Simple je kalau you look on this topic. So if you want to look the population and if you look birth is birth weight, not birth okay, so the weight is a variable. And then what else? For sample of size 200, so what is the mean? So mean is 3369. So you need to use this notation. Don't simply put 3369. So 3369. Okay, you need to put a notation there because it need the mean and standard deviation of sample. So you need to write the notation. So the notation said that the population for the mean samples, okay, will be equal to the mean of population equal to 3369. So katalah in the exam you put 339 tak ada markah you need to use retention. Kena tunjuk dah. So if you just put 339, maybe that is the mean population, but you want to stress here the mean population will be equal to the mean sample. Okay, and then for what you call the standard deviation, so the standard deviation here, so take the 581 grams. So ambil yang 581 dah, tak payah, no need for you to calculate the standard deviation. Just take the standard deviation for the population and then divide the size of population, size of mean. Okay, the sample size is 200, so you put 200 there. So you will have 41.808 grams. And then what else? Okay, for sample of 400, so 400s will be 400 lah. 400s. So divide with 400s and then you will have 29.05 gram. 05 gram. So in this exercise too the same. So the mean price of new mobile, so the variable is price. The variable for this is a price. For new mobile home is 65,100. Assume a standard deviation is 702,000. ringgit, 7,200. That denote the mean price of a sample of new mobile home. So for sample size 50, find the mean and standard deviation of X and repeat part 500. So we have that. I just show you the answer. So for number A, the sample size will be 65,100. And then for standard deviation of the sample, sample mean will be over the size, over 50, and then the standard deviation is 7,200. So just put 7,200 divide with standard sample. Okay, and then with 100 sama dah, just put the 100 there. So simple ni topik ni. So hopefully topik ni boleh score lah untuk topik ni. Cuma you need to prep betul notation tu and know what is the size sample. Sample. So finish for chapter 7. So I think I stop here. Stop here dah 10 minit.